Light, Reflection and Refraction. Part 4. Lenses. A lens works on the principle of refraction. Two types of lenses are concave lens and convex lens. Convex lens is converging lens because it brings together parallel rays to a point called principal focus F. Concave lens is diverging lens since it diverges parallel rays of light. The focus is virtual on the same side of the lens. Image formation by convex lens. Depending on where the object is placed, the nature, size, and position of the image change. For example, if the object is placed at infinity, the image formed will be real, inverted, and highly diminished, and the position of the image will be at focus. Let us take one example and draw the diagram. A convex lens is thicker at the center and converges light rays that pass through it. It can form real or virtual images, depending on the object's position. Here in the example, the object is placed at infinity means very far away from the lens. The image formed at focus, f2, the nature of the image formed is real and inverted. The size of the image formed is diminished or smaller in size. Image formation in concave lens. For concave lens, the light ray diverges as if they are coming from a point called the focus, f1, on the same side of the lens. If we keep object at any position, the image formed shall be between f1 and O, and the image will be virtual, erect, and smaller in size. Power of a lens. Ability of lens to converge or diverge light is the power. The formula is P equals 1 by F, where P is power and F is focal length. The unit of power is diopter. The focal length and power are positive for a convex lens, and negative for a concave lens, as per the new Cartesian sign convention. Magnification by a lens. Magnification tells how big or small the image is compared to the object. The formula is M equals HI by HO, which is also equal to V by U, where HI is height of the image. HO is height of the object, V is image distance. U is object distance. If M is greater than 1, image is magnified. If M is less than 1, the image is diminished. If M equals 1, the image is same size as the object. Lens formula gives the relationship between object distance, image distance, and focal length. It is written as 1 by F equals 1 by V minus 1 by U. While doing problems, you have to be aware of the sign convention. All distances are measured from the optical center. Distances measured in the direction of incident light is taken as positive. Distances measured opposite to the direction of incident light is negative. Heights above the principal axis is positive. Heights below the principal axis is negative. Also for concave lens F is negative. For convex lens F is positive. Lenses are designed in labs using the lens formula. Functioning of a lens in human eye. The light rays first pass through the cornea, which does most of the refraction, bending of light. Then, the rays pass through the aqueous humor and reach the eye lens. The eye lens, which is thin and least curved in this state, slightly bends the light rays. These refracted rays converge at the retina, the light-sensitive screen of the eye. The yellow spot is the most sensitive part of the retina. It gives the sharpest and clearest vision. Let's look at the image formation. A real, inverted, and smaller image of the distant object is formed on the retina. The retina converts this image into electrical signals, which the brain interprets as an upright, clear image. When a person looks at a distant object, ciliary muscles are relaxed and the lens is thin or less curved and the focal length is longer and the rays are parallel. When a person looks at a closer object, ciliary muscles are contracted and lens become thick or more curved. The rays from the object diverges. This change in the lens shape helps keep the image sharp on the retina. A short-sighted person can see near objects clearly but distant objects appear blurred. Short sight can be corrected by using diverging lens. Long sight is opposite to short sight. A person can see distant objects clearly but near objects appear blurred. Long sight can be corrected using converging lens like convex lens. Prism. When light passes through a prism, it bends or refracts and splits into its constituent colors, a phenomenon called dispersion. This happens because each color of light has a different wavelength, causing it to bend at a different angle as it passes through the prism. The violet light bends the most, and red light bends the least. resulting in the visible spectrum of colors. Many optical devices, like cameras, microscopes, telescopes, use prisms. Prisms are used in spectrometers to analyze the spectrum of light in laboratories and research. Video by Anand Mohandas.